Hey everyone, welcome to the second episode of our GitHub monitoring dashboard project. So in this video, I'll walk you through two Python scripts designed to streamline your GitHub monitoring process. So the first script automatically fetch recent GitHub commits, converts timestamp to your local time and stores them in a MongoDB database, making it perfect for tracking repository updates. And the second script leverages Streamlit to create an interactive dashboard that visualizes this data, allowing you to analyze commit activity in real time. So let's dive into the code and bring this automation to life. Import necessity library first, import OS, import requests, import paids from data from datetime import datetime and time delta and import time from pymango import mongo client and from .env import load .env. So after that load environment variables, copy the mongo connection and paste it. We need a token for github access. Creating a base URL for GitHub API. So this is the HTTPS semicolon api.github.com. Now for connecting the MongoDB database, so Mongo client database equal to client. After that, for accessing the GitHub, so we need authorization for headers. For authorization, create a headers. For securing the access, create the authorization. A string bearer and token. Token is your GitHub API token, and accept. So specify the API version to use. After that, so list the repository name to monitors. Repository to monitor, making a variable repositories. So give the owner of the repository. So I am choosing one of the open source Langflow AI, and their repo is Langflow. Choose as many as you want. So I one drag one more free code camp. Their owner name and their repo name is same, which means free code camp. And one more repo track TensorFlow. The same owner and repo TensorFlow. Okay. Now what I did, so now I'm converting your UTC to IST. So when we track our repository, so it's give a UTC time. So I convert into UTC time into the IST, creating a function def get IST times UTC times. So I'm using a try with try. First IST equal to bits dot time zone Asia Kolkata and return UTC time zone dot S time zone IST. For handling the error, I use try and accept log. So accept exception as e. So print f string error converting time to IST. So if there is any error, so it gives an return UTC time. So if there is any error, so it's return UTC time. So our code does not affect. If time is not converting, our code does not affect. Now give the fetch recent commits. Okay, so using the creating a function def fetch recent commit, and for this we using honor and repo. So give the URL. This is the format of any commits from GitHub. Okay. And what we did is get a response from URL. So it's the response equal to request dot get headers, and also using the parameters or params. Okay, now give the parameter also and saving into a variable params to params. So using the since, so ensure only commits from the last hour. Okay, UTC now time delta hour equal to 1. That ISO format. Now what is, so if response dot status code equal to 200, so mean process has successfully respond. Okay, so commits equal to response.json. It's response into a JSON data. So saving into variable commits. So for commit in commits, so extract commit details like in repo. Repo commit message author state URL. We are fetching these types of data. So for uh, commit message author, from the response commit author name and date, like commit author and date. For the saving the URL, commit and HTML URL. And one more thing, like which time I fetched. So fetched it, get IST time, copy the function name, get IST time and date time dot UTC now. So it's first fetch the data as the UTC time and convert into the IST. If it's fail, so it's written into UTC time. So our code does not fail. After that, what I did, so try to avoiding uh, the duplicate commits. So if the comment already exist in the database, so if not, commit collection dot find one URL and commit HTML URL. So commit collection dot insert one commit data. Print like f string stored commit. From repo. else print mm, duplicate commit skipped. So what this code does, so it's the check if the commit already exists in the database, so using in URL, and if not, to store the commit if it's new, otherwise skip it. Using the accept exception as the error processing committee, so else print fail to fetch repo. Also did HTTP status and response code. Accept exception as the, so print f string error fetching commits for honor repo. So these are the handles error during the data extraction. So ensuring the program does not cracks. Okay, now monitoring all repository, creating a function def monitor repositories for repo in repositories, try uh, print fetching commits for repo, try fetch recent commit, repo owner name and repository name. Accept exception as e, print f string error monitoring repository. Print monitoring cycle completed in a new line. So this script loop through the list of repositories and fetching the recent commits for each. Now creating a main loop. So if name equal to main, while true, try monitor repositories, time.sleep 3600. So it's run the monitoring process continuously and pausing for an hour between cycles. Except keyboard interrupt, print monitor stopped by user, then break it and accept exception as e, print error in monitoring loop. So let's save it and run it. So python fetch commit.py, it's throwing an error in the line number 70. Okay, it's showing the inverted comma error. Now correct it. Once again, save it and run it. It's now it's showing 72. I think it's the same error for other line also. Now correct it and rerun it. Showing one more error. In line number 70. Once again run it. It's fetching the data for lang flow. Okay. Now fetching command from tensor URL, TensorFlow. Now showing the our MongoDB database. It's fetch or not, and saving into the MongoDB. Let's wait. Now we see the collection name commits and document 3. It's mean there are three commits we are fetching. One for TensorFlow, FreeCodeCamp, and okay, that's it for the first script. Now move to the second script for dashboard. Just like that, starting with the import the necessity level libraries. After that, so fetch data from MongoDB. So creating a function def fetch data to get Mongo client, saving it a variable client. Now creating a variable data equal to list client dot find. So for excluding the MongoDB object ID, okay, underscore ID. Already show you ID. The MongoDB when save any object, it's creating a ID in MongoDB. Okay, what it did. So now return pt.data frame data. So convert the MongoDB result, which is our list of dictionaries, so into a data frame for easy manipulation. Okay, now starting the Streamlit configuration. So page configuration. So st dot set page config. So give the title page name. So GitHub monitoring dashboard and layout white. So st dot title GitHub monitoring dashboard. So display the main heading of the dashboard. st.markdown. So give the brief description to inform user about the app purpose. So view and analyze GitHub commit activity from monitor repositories. Now using the loading and pre-processing. So using a with st.spinner loading data. So it's spin while fetching the data and fetch data to equal to commit data, commit data. So it's fetched from MongoDB and store in the commit data variable. Okay. Now conditional check. So if data exists, so if not, commit data.empty. pt.to.datetime, commit data to date. So convert the date column into a proper data date time format for easier filtering and visualization. Display the raw data. So st.subheader, recent commit overview. With st.expander. So collapsible section to toggle the visibility of raw data. So show or hide raw data. And st.data frame commits data and use container with equal to true. So it's to display the data frame into a tabular format. Now creating the filters. st dot sidebar dot multi select. So select repos. So option equal to commit data repo. st.sidebar.text input. So it's create a user to filter the author name, and function dot lower convert the lowercase for case insensitive matching. Save into a variable author underscore filter. Now apply filter based on two conditions. So check the repository name is in the selected repo list, and check the author name content commit data repo is in repo filter. Check if the repository name is the selected repo filter, and commit data author dot str dot lower dot str dot contains author filter and na equal to false. So why we choose na equal to false? It's about the errors caused by a missing value in the author column. Now show the filtered data st.subheader filtered commit overview. So it's added a subheader and title filter commit overview in the main content area of the dashboard. If not, filter data.empty st.data frame filter data. It shows display the filter data in an interactive table. Use container with equal to true. Ensure the table expand to the fit width of the container. So if else st.warning no data matching the filters. So its filter data is empty. So a warning message is displayed using st.warning. For visualization, if not filter data.empty, chart data, filter data.group by, and filter data date.dt.date. So group the data by date and count the number of commits per day. Saving into a variable chart data. So st.line chart. So it's create a line chart if data is not empty. Commit count by author st.subheader. Now creating a bar chart for author. So st.subheader commit count by author. If not, filter data.empty. Filter data author dot value counts. So count the number of commits for each author and save into the variable author chart data. st.var chart So it display a bar chart showing the number of commits per author. Else a stated warning, no data found in the database. Now let's run this stream app. Streamlit run dashboard.py. It's running. Now our app is created successfully, showing the proper dashboard. A filter is also working. You can see commit count by author showing in a bar chart. You can also download a CSV file. That's all for today's video. If you enjoyed it, please give it a thumbs up, share it, and don't forget to subscribe for more. And in the next episode, I'll show you how to deploy this project on AWS EC2. Thanks for watching and see you next time.